Now that we've looked at some specific examples of complex number addition and multiplication, let's work out the general case for complex number addition. Suppose that we have a plus jb, and we want to add it to c plus jd. Now in this case, A, B, C, and D, A, B, C, and D are all elements of the set of real numbers. That's how we write that, by the way, in theoretical mathematics. A, B, C, and D, any one of them can be any real number whatsoever, positive, negative, or zero. So these are two general complex numbers. Notice that they are binomials. In order to add them, we simply add the real number parts together to get the real number part of the resultant. Pardon me, we're not multiplying there. We're adding. I'm getting ahead of myself. A plus C is the real number part, and JB plus JD is the imaginary number part. Now we can add the JB and JD by simply factoring out the J. So we get A plus C plus J times B plus D. By the way, these two parentheses, this one right here and that one right there, technically aren't needed here in this expression. But I've put them there just to differentiate the real number part of the complex number here from the imaginary part here. I had a professor in college. He was probably the best professor I ever had in my freshman year, the very first semester. The name of the college was Carleton College in Northfield, Minnesota. I will not name the professor because I don't want anyone to give me any grief over this, even though it's been 30 years plus. But this professor saw an expression like this where I included some superfluous parentheses. And he didn't like that. He said that they were useless and that my writing them showed that I wasn't thinking. This same professor, by the way, was dreaded by many of the students because, as the rumors had it, he was very tough on grading. But as I recall, this professor was the best professor I ever had. I loved his class. He was tough, but I learned stuff in there, and he made it fun because he made mathematics rigorous and something like a refuge from the humdrum everyday life, which back in 1972 had a lot of aspects to it that we are being reminded of even today. The other thing about mathematics that I might remark of is never fear. There was another course that I had later in college where people said it was one of the most difficult courses that you would ever have to deal with. The course was called Vector Analysis. Maybe someday I'll do a playlist on vectors, although I won't get much into vector analysis, also known as vector calculus. But vector analysis was, I was warned that this was going to be a terribly difficult course. The professor I had was a hippie from Berkeley. This was in, I guess, 1974. Still back in those good old 70s. And this guy was so great, he made that stuff seem simple. I'd ask, I think the book is wrong. How come they can't do it this way? And he'd say, well, the book is wrong. You can do it that way. He was great, too. But when you get to complex numbers and add them, getting back to the subject at hand, I like to digress. When you add complex numbers, you simply add the real number parts and add the imaginary number parts separately. That's all you need to remember about that.